In this example, we will graph the equation x minus 3 squared over 4 plus y plus 2 squared over 9 is equal 1. This is the standard equation of an ellipse. The center of that ellipse is at the point 3 and negative 2. In the standard equation of an ellipse, the numbers in the denominators are a squared and b squared. And since a squared is always greater than b squared because a is always greater than b, we can conclude from that equation that a squared is equal 9 and the b squared is equal 4. Now if a squared is equal 9, that a is the square root of 9 and therefore it is 3, we are assuming that a is positive, and the b is going to be 2. On the other hand, the value of a is the distance between the center of the ellipse and a vertex. So the distance in this case is 3. And the b is the distance between the center of the ellipse and the endpoint of the minor axis, which we are denoting by b. Also, a squared in the equation appears together with the y variable, and therefore this tells us that the major axis is the line parallel to the y-axis. So if we combine all this information, we know that the center is at the point 3 and negative 2. So this is the center. We know that the vertices are contained in the vertical line going through the center. And since we know that the distance between the center and the vertex is a and a is equal 3, we can get the vertices by simply starting at the center and moving 3 units up to get the vertex v sub 1 and 3 units down to get the vertex v sub 2. And therefore we can write the coordinates of those vertices. Vertex v sub 1 has x coordinate 3 and the y coordinate 1. Vertex v sub 2 has x coordinate 3 and the y coordinate negative 5. Value b, which is 2, will be used to find the endpoints of the minor axis. Since the major axis, a line going through the vertices, is vertical, the minor axis will be horizontal and will pass through the center. And since the b is the distance between center and the endpoint and b is equal to, we'll go 2 units to the right to get one of the endpoints and 2 units to the left to get the other endpoint. And once we have those 4 points, we are ready to draw the ellipse. We'll draw the oval shape going through those 4 points. The last thing to do is to find the coordinates of the foci. To find those coordinates, we need the value of c. So we'll use the relationship that b squared is equal a squared minus c squared, which will give me that c squared is a squared minus b squared, and therefore it's going to be 9 minus 4, or 5. And therefore c is the square root of 5 because the c is positive. So c is also the distance between the center and a focus. So to get the focus on the graph, we'll have to start with the center and move square root of 5 units up and the square root of 5 units down from that center. So square root of 5 is about 2.2, so we'll move square root of 5 up to get the focus f sub 1, and we'll go square root of 5 units down to get the focus f sub 2. The coordinates of the foci will be obtained by using the fact that the foci are really vertical shifts of the center. So since we are shifting vertically, x coordinate stays the same as the center. The y coordinate of the center was -2, but now it was shifted square root of 5 up. So this is the coordinate of the foci, focus f sub 1. And the other one will be 3 and -2. This time we'll reduce this by square root of 5, and this is the coordinate of the focus f sub 2.